Say you're given a number and you're asked to check whether that number is a prime number or not. Let's see how we can solve this type of problems. For this, we need to remember that factors of a number occur in pairs. Now, what do I mean with that? Say, let's take the number 6. Now, I know that 6 is equal to 2 into 3, right? Now, if I say that 2 is a factor of 6, along with 2, I also get 3, right? Because when you divide 6 by 2, you get your quotient as 3 and your remainder is 0. This indicates that if I divide 6 by 3, I will get the quotient 2 and the remainder is 0, right? Therefore, I can see that factors occur in pairs. Alright, now using this concept, say you're asked to check whether 47 is a prime number or not. For this, there is an easy method that you can employ. Find the next higher number that is a square number. Over here we have 47. Let's do some trial and error. 6 square is 36. So that's not greater than 47. So let me try another one. 7 into 7, that's 49, and 49 is greater than 47. So 7 works. Alright. Now you only need to check prime numbers up to 7 to check whether 47 is a prime number or not. What are the prime numbers up to 7? You have 2, 3, 5 and 7. So you just need to check whether 47 can be divided perfectly by 2 or 3 or 5 or 7. And you will see that 47 cannot be perfectly divided by any of these 4 numbers, and therefore, yes, 47 is a prime number. Now, let me also tell you one interesting thing about prime numbers. Always remember this, any prime number is of the form 6k plus or minus 1. What do I mean with that? Let's take our example over here. We have 47, right? Let's see whether this is of the form 6k plus or minus 1. Now, I can see that 47 can be written as 6 into 8 minus 1. 6 into 8 is 48. 48 minus 1 is 47. Therefore, you can remember this. This is an interesting property which can help you in many different types of situations. Any prime number is of the form 6k plus or minus 1. But at the same time, remember that any number which can be expressed as 6k plus or minus 1 is not necessarily a prime number. Alright. So it's just one way. If you can find out that a number is not of the form 6k plus or minus 1, directly you can conclude that that number is not a prime number. But given that a number is of this form is not a sufficient enough condition, that's why we need to employ this method which we discussed over here. Now, let's quickly try to solve 2 problems to establish what we have learned in this section. We are given 2 numbers and we are asked to check whether they are prime numbers or not. Now, when it comes to checking the divisibility of a number by 2, 3, etc., do remember to check the divisibility rules section and you will get some easy tricks to find whether 2 or 3 or any of these numbers divides perfectly a given number. Now, let's try to solve this problem only with the concepts that we have discussed so far. Let's take 783. Let me check whether this is of the form 6k plus or minus 1. So 783 divided by 6 gives me a quotient of 130 and I'm left with a remainder of 3, right? If I do this normal division, this is my quotient and I get a remainder 3. Therefore, 783 is not of the form 6k plus or minus 1 and hence it's not a prime number. Alright. Let's try 143. If I divide 143 by 6, I'll get 23 as the quotient and my remainder would be 5. So this implies that I can write 143 as 6 into 23 plus 5, right? Try to do this along with me. Pause the video and keep working along with me. Now, 6 into 23 plus 5 is one way of writing 143. I can also write it as 6 into 24 minus 1, right? What did I do? Here I had 23. I took the next number, that's 24, and I have a negative remainder over here. So that's an interesting concept. You can note that a remainder of 5 or a remainder of minus 1 actually means the same in case with respect to reminders. Now let's keep this aside, and you can see over here 143 is of the form 6k minus 1. So the first criteria is satisfied. Now we have discussed that this alone is not enough to establish 143 to be a prime number. If this was not the case, if 143 was not of the form 6k plus or minus 1, we could have eliminated 143 from being a prime number. But now, as that condition is satisfied, let's check using the method that we discussed before whether 143 is a prime number. So the first step is identify the next higher square number, and we know that 12 square is equal to 144. Therefore, you need to check primes up to 12. You need to check whether those numbers will divide 143 or not. Now, what are the prime numbers up to 12? The prime numbers up to 12 are 2, 3, 5, 7 and 11. So you have these 5 prime numbers, and when you check whether 143 is divisible by each of these, you will see that 143 divided by 2 gives you a remainder 1. So it's not divisible by 2. If you do 143 by 3, right, you will get 14 by 3, that's 4, it goes 4 times, you get a remainder 2, and you add 3 to it, that's 23 by 3, it goes 7 times, you get 21, and your remainder is 2, right? In a similar manner, you will see that 143 cannot be divided by 5 and 7, and we have already seen that 2 and 3 are not dividing perfectly 143. But when it comes to 11, if you do 143 divided by 11, you will see that first you take 14 by 11, it goes 1 time, your remainder is 3, and you take this 3 along with it, so 33 by 11, that's 3. So yes, 143 is perfectly divisible by 11. Therefore, we conclude that 143 is not a prime number.